Hello. Okay, good afternoon, partners. Today I'm gonna to watch the lecture number 4. So I hope you enjoy it. I hope you are studying. Meanwhile, I'm studying. And then that's it. So, yes, let me open the window. Yeah. And lecture number 4 is about libraries. So libraries, it's about models, it's about the keyword import, and I understand that that's important because when you install Python has a lot of functions. But if you want to use a specific function in order to do a specific task, for example, for instance, graphics like visual video games or or artificial intelligence, that kind of stuff, you have to use libraries, okay? Because when you install Python, you don't have that libraries when you start, so you have to import that libraries, and you are able to use that functions. Yeah. So yeah, we're going to start with that library. The concept of libraries, I think I already understand, but we we were in command line argument sys. Argument sys is a function that you have to import uh, before you be able to use it. So that's it. We're going to we're going to watch the whole video, and then we are going to, if we have time enough, we can start with API calls. That looks really interesting because I have always heard about that. APIs. I don't understand. I don't know what is that, what it's supposed to be. So, okay, we're going to start. I'm really excited. How can difficult how can difficult it could be that? Okay, let's go. I'm gonna to be mute and hope we are start. Okay, Chronos start in 1 hour or 2 hours. 1 hour or 2 hours. 2 hours, 1 hour. 1 hour. Yeah. Yeah. Okay. Listen. Okay.
To bracket 1 here. So clearly, sys.argv bracket 1 is storing DAVID, but it's 1. In the past, when we looked at loops, recall that we said that they were 0 indexed. That is, the first element is 0, the next element is 1. Python, and there's this feature generally known as command line arguments. This is a feature not just of Python, but of languages more generally, that allow you to provide input not when prompted inside of a program, as happens whenever we call the Python function input, but rather there's this feature, command line arguments of programs, that allows you to provide arguments, that is input to the program, just when you're executing it at the command line. So up until now, for instance, recall that we've generally run Python of something.py, for instance, Python of hello.py. And I've never once really executed any words or phrases after the name of the file. but I could. In fact, when you're running programs in a command-like environment like we are, you can provide any number of words or numbers or phrases after the command that you're typing, and all of those will somehow be passed in as inputs to the program itself. You don't have to prompt the user for one thing at a time by manually calling that input function. So what does this mean in real terms? Well, let me go ahead back into VS Code here, and let me propose that we consider how we might leverage a certain module. I'm going to go ahead and create a file called name.py, and I'd like to use a new module this time that's going to give me access to values that have been typed at that command line. But what's this module going to be? Well, this one's going to be called sys. And sys, short for system, contains a whole lot of functionality that's specific to the system itself and the commands that you and I are typing. The documentation for this module is at this URL here, and it lists all of the various functions and variables and the like that come with that module, but we're going to focus on something a little more specific, namely this thing here. It turns out in the sys module in Python, there is a variable that just magically exists for you called argv. It stands for argument vector, which is a fancy way of describing the list of all of the words that the human typed in at their prompt before they hit enter. All of those are seemingly magically provided to you via Python in a variable called sys.argv. This variable is a list, which means that the first element's going to be the first word that you typed, the second element's going to be the second word that you typed, and so forth. And by way of this list then, can you figure out what words did the human actually type at the prompt and maybe use that to influence the behavior of your own program? So what does this mean now in real terms? Well, in this new tab called name.py, let me go ahead and import sys. Within that sys module is going to give me access to sys.argv, but how might I want to use it? Well, let's do this. Instead of writing a hello world program that all of these times has just looked for the return value of input to figure out what the user wants me to print, let's go ahead and just expect the user to tell us when they run the Python program itself what their name is. And suppose this time I'd like to generate a whole bunch of name tags, initially just one, and in the US here it's very common to wear a sticker on your lapel that says, hello, my name is David, so I want to print out some text that resembles that. The idea being maybe I could enhance this program someday to even send that text straight to the printer and dynamically generate those name tags. Well, let me go ahead now and do this. Let me go ahead and print out, as always, hello, but I'll say a little something more this time to make things more interesting. Hello, my name is, quote unquote. And then after that, I normally have been in the habit of calling input, storing the return value in a variable, and passing in the name of that variable here. But I'm going to instead jump right to this, sys.argv bracket 1. And that's it. I'm going to have a program here that says, hello, my name is, followed by whatever is in sys.argv bracket 1. And notice sys.argv again is a list. And recall from our discussion of loops and intern lists, we use this square bracket notation to get at the various elements inside of a list. All right, let me go down now into my terminal window and run Python of name.py, but this time, rather than just hit enter and wait for the program to prompt me for my name, let me proactively just tell this program what my name is at the so-called command line. Here we go, DAVID separated with a space from the name of the file, so that now when I execute Python name.py David, I see on the screen, voila, hello, my name is David. So based on this demonstration alone, I think we can infer exactly what's going on in sys.argv, even though it sounds certainly, at first glance, rather complicated here. Let's look up. At sys.argv, I'm going to bracket 1 here. So clearly, sys.argv bracket 1 is storing DAVID, but it's 1. In the past, when we looked at loops, recall that we said that they were 0 indexed. That is, the first element is 0, the next element is 1, the next element is 2, and so forth. And yet here I am treating it as though my name is at the start of the list 1. Well, let me ask this question. What is probably in sys.argv of 0? What is probably in sys.argv of 0? The very first. What is that they were 0 indexed? That is, the input 1 is storing DAVID, but it's 1. In the past, when we looked at loops, recall that we said that they were 0 indexed. That is, the first element is 0, the next element is 1, This next element is 2, and so forth. And yet here I am treating it as though my name is at the start of the list 1. Well, let me ask this question. What is probably in sys.argv of 0? What is probably in sys.argv of 0? The very first element actually in that list.
Oh, yeah. I think it's like in C, the name of program.
Indeed, it's indeed, like in C and other languages, the name of the program. Well, if we consider what it was I typed, I certainly typed Python, because that's the name of my interpreter, and we don't really need to know that because we're using Python itself. But after that, I did type 2 things. I typed name.py, as I've done so many times, anytime I want Python to interpret a program I've written. And it turns out by convention, what Python does is it stores in sys.argv the name of the file that you're executing or interpreting, followed by any number of other words that you typed. So all this time, we could have been accessing the name of the program, which frankly isn't all that interesting, but we can also now access words that are typed after that prompt as well. But of course, if I don't type anything in, what might happen here? This might be naive of me to assume that there's always going to be something at location 1 in sys.argv. Let me go ahead and try this. Python, name.py, and no, I'm not giving you my name because at this point I might not even know that you want my name to be typed, so let me hit enter now, and uh-oh, we see now an error. A so-called exception in Python. This one's a new one. This one's an index error that elaborates list index out of range. And turns out this is actually one of the most common mistakes in programming, whether using a list in Python or arrays or vectors in other languages, is to try to access some element that does not exist. You try to go too far to the left, or you try to go too far to the right in this object that is just a list of some values. So of course, the mistake here is that I'm assuming there's going to be something at location 1 when really it's location 0 that's the only one that has a value. But fixing this is not going to amount to doing bracket 0, because now if I go ahead and rerun this program with no other words after name.py, it says, hello, my name is name.py, which is fine if we're making a name tag for the program, but that's not, of course, what my goal here is instead. So if the fix is not just to change the 1 to a 0, how else might I handle this error? How else might I handle this error? This index error that happens if the user just doesn't remember to or doesn't know to type their actual name at the prompt.
We could always put an exception into the program saying if there's nothing at location 1, we just come out to say, well, okay, we haven't got a parameter or something. But if there is, you continue along with the program.
Perfect. So if I might simplify, we can try to execute this line of code, except if there's an error, we'll deal with it in some other way. Now, ideally, and once I'm a strong enough programmer, I would have anticipated this and written the following code from the get-go. But when you're learning, it's certainly reasonable to see an error. Oh, I didn't realize I should detect that, and then go back and improve your code. But of course, if you read the documentation, you ingrain some of the lessons learned from the past, you'll get into the habit of trying and checking for some of these exceptions yourself. So let me solve this in one possible way, as you proposed here. Let's try to handle this exception as follows. Let me go ahead now, and instead of just blindly calling this print line, let me try to print out, hello, my name is such and such, except if there is an issue, specifically an index error, then what do I want to go ahead and do? I'm going to say something like too few arguments. I could be more explanatory than that, but for now I'm just going to explain to the user that they gave me too few arguments, too few words at the prompt. So now it's still not going to work in quite the way I want. I'm still not going to be able to generate their name tag, but at least they're not going to see some cryptic error message and think that they themselves broke the program. Let me go ahead now and run Python of name.py, enter, and too few arguments. Okay, let me go ahead now and do Python of name.py and type in my name, David, and now we're back in business. And I see that my name is on the screen too. But strictly speaking, I don't have to try to do this. I could actually be a little more defensive in writing this code, and maybe I could check whether or not the user has indeed provided a name or multiple names at the prompt so as to give them more refined error messages as well. So how might I do this? Well, let me go and undo the exception handling I've added, and why don't I instead more modestly try to do this? Let me go ahead and introduce a conditional here. If the length of sys.argv is less than 2, or equivalently equal to just one value, but I'll just stick with less than 2 for now. Then go ahead and print out too few arguments. So I want ultimately 2 arguments. I want the name of the program at location 0, and I want the name of the human at location 1. So that's a total of 2 arguments. So if I have fewer than 2 arguments, let's tell the user with this print line, if the length of sys.argv is, say, greater than 2, like they typed in too many words at the prompt, well, let's tell them print, quote unquote, too many arguments. Else, if they did get it right and they gave me exactly 2 arguments, else, let's go ahead and print what I actually care about. All right, let me go down to my terminal window here and run python of name.py, and voila, a completely different type of error. This one, a syntax error, which we've seen in the past. Now, a syntax error, recall, is mea culpa, like I messed up here and I wrote invalid syntax, and so no amount of conditionals or exception handling is really going to catch this one. I need to go back and just get my program to work because it's not running at all. Well, let me go up here and see. Line 4 is the issue, and indeed, it looks like I have an unterminated string here. I need to go ahead and now add this double quote. So let me go ahead now, and with that red herring gone, let me rerun python of name.py and hit enter, and now we see too few arguments. Okay, maybe it wants my full name. Let me go ahead now and run python of name.py, David Malin, typing in both words after the name of the file and hit enter. And now, of course, it's too many arguments. Fine, now I'll oblige and do python of name.py and just David, and there we have it, my name tag printed on the screen. So strictly speaking, we don't have to handle exceptions if we can be a little smarter about it and just check for the things that we're worried about, especially if we want to give the user more refined advice. We don't want to just tell them, no, something went wrong, or we don't want to pass. We want to tell them, no, that's too few. Or no, that's too many. We have conditionals in our vocabulary already via which we can now express that. Well, let me pause here and see if there's any questions now on how we handled the error before with the index error, or how now we're just proactively avoiding all index errors altogether by just checking first, is it too few, is it too many, or is it exactly what we want?
Hiya, thank you. So I was wondering, you touched upon kind of using your full name. So I was wondering, you touched upon kind of using your full name. Could we then, is there a way going forwards that perhaps we have people that want their full names and want just their first name, that we separate that into like, oh, this person has full name, this person has just the one name?
Absolutely, and allow me to propose we come back to that support for multiple names. But indeed, we could do that. And I should note, too, though, we can support full names right now if I do this. Instead of typing in David space Malin, which is problematic because, again, by definition of how argv works, each word ends up in a specific location in the list. But if I add quotes, single quotes or double quotes at the command line, now Python will view this as 2 total things, the name of the file and this full name. And now when I hit enter, I don't see the quotes. The whole thing is passed in as my full name. And if I want to adapt this further for multiple people, we'll be able to do that as well. Other questions now on this version with if, else, or on except before?
Hi, sir. I want to ask you, can we use multiple else statement?
Can you use multiple else's statements? No. Else is the last catch-all statement that you can have. You can have multiple if statements in the middle, but not multiple else's. All right. All right, well, let's turn our attention back now to this code and see if we can't refine it a bit more by adding in some additional functionality that we get with modules like the sys module. One of the things I don't love about this version of the code, even though arguably it is now correct, is that the essence of my program, which is just to print out the name tag, is kind of relegated to this else clause. And that's fine. Logically, it's correct. But generally speaking, there's something nice about keeping all of your error handling separate from the code that you really care about. Having all of these ifs, elifs, perhaps at the top of your code that are checking to make sure that all of the data is as expected. But then it would be nice, if only for design's sake, not to sort of hide in this else statement the actual code that you care about. I would prefer, for instance, to do something logically like this. I could check for errors up top, and then down here, print the name tags. It would be nice if those are sort of distinct blocks of code, all of which are here left aligned. But there's a problem with what I've just done here. Logically, what bug did I just introduce by getting rid of the else and introducing line 10 on its own with no indentation outside of the conditional? What bug have I just introduced? What mistake, to be clear? Code that you really care about, having all of handling separate from the code that you really care about, having all of these ifs, elifs perhaps at the top of your code that are checking to make sure that have tag correct, is I don't want some additional functionality that we get with modules like the sys module. One of the things I don't love about this version of the code, even though arguably it is now correct, is that the essence of my program, which is just to print out the name tag, is kind of relegated to this else clause. And that's fine. Logically, it's correct. But generally speaking, there's something nice about keeping all of your error handling separate from the code that you really care about, having all of these ifs, elifs perhaps at the top of your code that are checking to make sure that all of the data is as expected. But then it would be nice, if only for design's sake, not to sort of hide in this else statement the actual code that you care about. I would prefer, for instance, to do something logically like this. I could check for errors up top, and then down here, print the name tags. It would be nice if those are sort of distinct blocks of code, all of which are here left aligned. But there's a problem with what I've just done here. Logically, what bug did I just introduce by getting rid of the else and introducing line 10 on its own with no indentation outside of the conditional? What bug have I just introduced? What mistake, to be clear?
Name error.
Ironically, it's a name error, but not a name error exception. It's an error. With my name, but I think you're frozen for me. It's going to raise an exception because even though I'm checking the length of sys.argv up top, and even though I'm checking it again for being greater than 2, not just less than 2, but greater, I'm still then blindly and incorrectly assuming it's now going to exist. So just to be clear, if I run python of name.py and I don't type any argument, I've got too few. I think I'm going to see that I have too few, but I'm also going to see that same exception. At the very top of my terminal Windows output, there's my error message, too few arguments. But again, on line 10, I blindly proceed to still index into my list at location 1, which does not exist. So it turns out there's a better way to handle errors like this, especially if you're writing a program in Python that's just meant to run briefly and then exit anyway. But maybe we could start to exit prematurely if the program itself just can't proceed. If the user has not given us the data we want, perhaps we should just exit the program earlier than we might otherwise. So let me go ahead and do this. Let me go ahead and remove my comments so as to focus only on the code here. And let me propose that instead of just printing quote unquote too few arguments, I'm going to use one other function that comes with the sys module. I'm going to go ahead and call sys.exit. And as the name suggests, it's going to do exactly that. With the system's help, it's going to exit my program then and there on line 4. Why is that okay? Well, if you gave me too few arguments, I have nothing more to say to you, the user. I might as well exit a bit prematurely. And I can do this as well on line 6. Let's go ahead and not just print that, but sys.exit, quote unquote, too many arguments. Print out that message and just exit right there. Now I can trust that by the time I get to line 8, every error condition has been checked for. That arguments. Print out. Let's go ahead and not just print that. Why is that okay? Well, if you gave me too few arguments, I have nothing more to say to you, the user. I might as well exit a bit prematurely. And I can do this as well on line 6. Let's go ahead and not just print that, but sys.exit, quote unquote, too many arguments. Print out that message and just exit right there. Now I can trust that by the time I get to line 8, every error condition has been checked for, and so it's safe for me to assume that there is, in fact, an item at location 1 in sys.argv. So let me go ahead now and run this. Python of name.py, enter, too few arguments, but I'm back at my prompt. Nothing more has happened. Let me run it again. Python of name.py, David Malin with no quotes, enter. Too many arguments is now printed here. Finally, Python of name.py, just David, enter. Hello, my name is David. So we have then in sys 2 forms of functionality now. We have access to this variable, sys.argv, this argument vector that gives me all of the words that were typed at the prompt, including the program's own file name. And it turns out, if we read further in the documentation, there's an exit function that can take different types of inputs, but if I pass it a string like this, it will indeed print that string for me and then exit from my program then and there. Questions now on exiting from programs like this. To be clear, all of this time, once Python gets to the bottom of your file, it's going to exit anyway, so I'm using sys.exit now just to make sure that I exit earlier than otherwise.
My question is about the sys.argv. So is that capable of accepting or taking multiple elements at once? Let's say, for example, Python name.py, David Malin, I'm a male, 20 years old. And if, let's say, I only want to access your name, which is at the first index, and then your age is say at the 6th index, can I say sys.rv1 and another one for 6 to access what I just want? Is that possible for sys.rv?
Short answer, yes, I think, if I understand your question correctly, whereby you're proposing to have many words at the end of the command and you want to access those individual words. Absolutely. At some point, it gets a little fragile, I would say, if you're typing so many words at the prompt that the order really matters. And so it turns out there's a lot of programs and there's functionality in Python that can allow you to provide those values like name or age or any number of other fields in any order you want, but pass in a bit more information textually that tells the program how you want to use it. So in short, what you're describing is possible. And let me do a small incarnation of it as follows. Let me propose that we go back to my code here, and let's propose that we actually now want to support multiple values at the prompt. So there's going to be no such thing as too many arguments. Suppose that I want to generate name tags, not just for David, but for David, for Carter, for Rongxin, for others in the group who all want their name tags as well. So I'm going to go ahead and do this. I'm going to get rid of my elif condition because I don't want to limit the maximum number of words that are typed at the prompt anymore. I instead want to iterate over every name at the prompt. So I'm going to say this. For arg in sys.argv, go ahead and print out, this time, arg. So what am I doing here? Well, even though the syntax is a little different, the idea is the same as before when we've had loops. I'm using a for loop to iterate over a list. The list in question here is sys.argv. Arg is a variable that I'm creating on the fly. The for loop is going to make sure that the first time through this loop, arg is set to the first word on the command line. The second time through the loop, Python's going to make sure that arg is now set to the second thing on the command line, and so forth. That's just how a for loop works. It updates the variable for us. I don't have to call it arg. I could call it name, so long as I change it to name in both places, but arg is reasonable if I'm iterating over arguments more generally. If I now run this program, though, unfortunately, there's a little bit of a bug. Even if I type in David and Carter and Rongxin, I'm not going to get just 3 name tags. in your mind, does anyone see the bug I'm about to trip over? It's not a huge deal if I've got enough name tags to go around, but I'm going to be wasting one because this is going to print not 3 but 4 name tags, whereby the first contains the name of the program itself. Maybe not a big deal. Maybe that's the sticker we don't bother handing out, but it's wasteful and it does look wrong. So how could we get access to not all 4 elements of argv, but just a slice of argv? And this is actually a technical term. In Python and some other languages, to take a slice of a list means to take a subset of it. Maybe from the beginning, maybe the middle, maybe the end. But a slice is a subset of a data structure like a list. Well, how do I actually do this in code? Well, in Python, it's actually very easy to take a slice of a list, that is a subset thereof. You can simply do this. At the end of the list name, sys.argv in this case, you can use square brackets, and then in those square brackets, you can specify the start and the end of the list that you want to retain. I want to start at element 1, not 0. I want to start at element 1, and I want to just go to the end. So I'm actually going to omit a second number altogether. It's not necessary to have a second number, but I do need that colon because this is going to give me a slice of the list. It's going to give me a slice of the list that starts at location 1, not 0, and the colon and then a blank just means it's going to give me everything else. So this is equivalently going to slice off the first element of the list and give me a new list that contains just those 3 human names, not the name of the file itself. Let me try running this again. I'm going to run Python of name.py, David, Carter, Rongshin. This time, hopefully, I'm going to get 3 and only 3 name tags. Hitting enter, and indeed, I've done now just this. So again, using some relatively simple syntax in Python, we can use square brackets not just to go to specific elements like bracket 0 or bracket 1. We can also get subsets of the list, slices of the list, by doing bracket something colon something, where each of those somethings is a number, the beginning or the end, and they're optional, depending on whether you want all of them or just some. Any questions now on this version, which adds the loop and these slices with that new syntax?
Can we slice starting from the end of the argument vector?
You can. You can slice something from the end of the argument vector, and this might blow one's mind a little bit. Let me go ahead and do this. Let's see. Let me go ahead and do -1 at the end, using a negative number here and running the same command. We've just uninvited Rongshin from receiving a name tag here. So if you use a negative number, it has the effect of counting to the in the other direction from the end of the list. A good question there. Other questions now on slices, on looping over system. .argv.
Hi. So I remember very early on when we were talking about only having 2 decimal places in float value. Does this is that in the same vein? Like because we use the colon 0.2f. So is that the same thing then? Why would the f be included then in the 0.2f as opposed to here when you just have the numbers?
A really good question, and it's just, the short answer is that context matters. So there's only so many keys on our keyboard, and so we sometimes use the same symbols for different things. So what you're alluding to is the format code in F string for actually formatting a number, using a colon, using a period, using a number, using the letter F, and so forth. And that is very specific to the F string feature of Python. This case has nothing to do with any of that syntax per se. This is just using a colon in a different context to solve this problem, to implement a slice. The authors of Python could have chosen another symbol, but honestly, looking down at my keyboard here, we don't have that many to choose from that are easy to type, so sometimes they have different meanings. A good question as well. Allow me to propose now that we take things further and move away from using only those modules, those libraries that Python comes with, to talk about more generally packages that exist. One of the reasons that Python is so popular and powerful these days is that there's a lot of third-party libraries out there as well, otherwise known as packages. Strictly speaking, Python itself has a term of art called a package, which is a module, essentially, that's implemented in a folder, not just a file, but a folder. But more generally, a package is a third-party library that
¿A qué aspiras a trabajar? ¿Trabajas actualmente? ¿Cuántos años tienes? Mm, muchas preguntas. Me voy a llevar a la policía o algo así.
Hola, soy Miguel y uso Bitrix 24 para gestionar proyectos porque me da la posibilidad.
that I can install on our own Mac or PC or our cloud server and gain access to even more functionality that other people have implemented for us. Now, one of the locations you can get all of these packages is called the PyPI website that I can install on our own Mac or PC in a folder, not packages. Strictly speaking, part of the reasons that Python is so popular, move away from using only those modules, those libraries that Python comes with, to talk about more generally packages that exist. One of the reasons that Python is so popular and powerful these days is that there's a lot of third-party libraries out there as well, otherwise known as packages. Strictly speaking, Python itself has a term of art called a package, which is a module, essentially, that's implemented in a folder, not just a file, but a folder. But more generally, a package is a third-party library that I can install on our own Mac or PC or only those modules, those libraries that Python have different meanings. A good question as well. Allow me to propose now that we take things further and move away from using only those modules, those libraries that Python comes with, to talk about more generally packages that exist. One of the reasons that Python is so popular and powerful these days is that there's a lot of third-party libraries out there as well, otherwise known as packages. Strictly speaking, Python itself has a term of art called a package, which is a module, essentially, that's implemented in a folder, not just a file, but a folder. But more generally, a package is a third-party library that I can install on our own Mac or PC or our cloud server and gain access to even more functionality that other people have implemented for us. Now, one of the locations you can get all of these packages is called the PyPI website, the Python Package Index, which lives at this URL here. And this is a website that is searchable via the command line as well as via the web that allows you to download and install all sorts of packages. Even CS50 has some of its own packages in services like these. Now, there's a fun one out there that's a throwback to a command that's been around for years in command line environments called cow_say. Cow_say is a package in Python that allows you to have a cow say something on your screen. If curious to read up on it, its own documentation is on pypi.org, specifically at this URL here. But how do you actually get the package into your system? Well, technically, you could figure out how to download the file and maybe unzip it and put it into the right location on your Mac or PC. But nowadays, a lot of languages, Python among them, has what's called its own package manager. This one here called pip, which is just one. So pip is the right location on your Mac or PC. But nowadays, a lot of languages, Python among them, has what's called its own package manager. This one here called pip, which is just one. So pip is a program that generally comes with Python itself nowadays that allows you to install packages onto your own Macs or PCs or cloud environment by just running a command, and then voila, you have access to a whole new library in Python that didn't come with Python itself, but now it's available on your system for you. Let's go back to VS Code here, and in my terminal window, I'm going to go ahead and type pip install cow_say. Now, what's going on here? Pip is the command, the package manager, and I want to install what package? The package called cow_say. I'm going to go ahead and hit enter here, and after a little bit of output, it has successfully installed cow_say. Now, what does that mean? That means I can now go about importing this into my own code. Well, let's go ahead and see what this means. Let me go ahead and create a new file with code called say.py, because I want something to be said on the screen. And in my new tab here, I'm going to go ahead and import cow_say, which presumably is now installed. I'm now going to import sys as well, because I'd like to see I can now go about input. It has successful. Pip is the command and type for you. Let's go back to VS Code here, and in my terminal window, I'm going to go ahead and type pip install cow_say. Now, what's going on here? Pip is the command, the package manager, and I want to install what package? The package called cow_say. I'm going to go ahead and hit enter here, and after a little bit of output, it has successfully installed cow_say. Now, what does that mean? That means I can now go about importing this into my own code. Well, let's go ahead and see what this means. Let me go ahead and create a new file with code called say.py, because I want something to be said on the screen. And in my new tab here, I'm going to go ahead and import cow_say, which presumably is now installed. I'm now going to import sys as well because I'd like to use some command line arguments in this program just so that I can run it quickly, and without using the input function, I can get the user's name immediately from the prompt. And let me go ahead and do this. I'm going to do a bit of error checking proactively this time, and rather than use less than or greater than, I'm this time going to say if the length of sys.argv does equal 2. So if the human is provided just the name of the program and their own first name, we're good to go. I'm going to do the following. I'm going to call a function called cow in the package called cowsay, and I'm going to pass in a string, hello, comma, and then, as in the past, I'm going to pass in just one string because according to its documentation, it's not like print. I can't pass in comma this, comma that. I can only pass in one string, so I'm going to concatenate the contents of sys.argv bracket 1. So long as then I type in my name, David, after the name of this program, it should end up in sys.argv1, in which case this line 5 of code should concatenate hello with my name, with a space in between, and apparently a cow is going to say it. So let's see what happens here. Let me go ahead and clear my screen and increase the size of my terminal window. Let me go ahead and run Python of say.py and type my name, David, and enter. There is the program called cowsay. It literally has a cow say something on the screen, and this is a throwback to a program from yesteryear that tended to come with a lot of systems. This is otherwise known as ASCII art. It's a textual way using just keys on your keyboard to print pictures of sorts on the screen. Now we can really go down the rabbit hole here, and there's questionable academic value of doing so I'll do so just once. Turns out the cowsay package comes with other functions as well. One of those functions, for instance, is T-Rex. And if I now increase the size of my terminal window, we'll perhaps see where we're going with this. Let me now run again Python of say.py. This time, let me not provide my name just to see if it's broken. It's still OK because we have that if condition. If the length of sys.argv equals 2, and only if it equals 2 do we do anything. That's why we're not seeing anything here. Let me go ahead and cooperate now. Say.py space David, and it's no longer a cow, but if I zoom out on my screen, a T-Rex. Why? Just because. These are the things you can do once you know. know how to program. You can even package them up and make them freely available to others as open source software. For us, it's demonstrative of a feature more generally here, namely being able to install these third-party packages and how you might do so in Python. Now, I'll leave this up on the screen for a moment and see if there's any questions about cows or Tyrannosaurus rexes or packages more generally. I'm really qualified to speak to just one of those.
Hi, I've got two questions. It's a bit earlier than what's supposed to be. So the first question is, the packages that you're calling to use in the program, are they the same as, let's say, because I'm doing Java, the same as calling a class of a Java file in order to use its functions? And my second question is, what's the actual purpose of using command line arguments as you use? Because it's not really the best way to, as you say, be user friendly. Where, as in, let's say the person who's using the program doesn't know what they want, what the program's asking them.
Really good questions. The first question about the comparison with Java. Python packages are similar to Java packages, where you have something dot something dot something at the top of your program that gives you access to a class or something else. Python itself supports classes, more on those down the road, and you can do very similar things in Python as you can do with Java. But the analog really is Python packages to Java packages here. As for command line arguments, you ask a good question. Why do we use them, especially if they're a little less user-friendly? They're a little less user-friendly to people who aren't in this Zoom, to be honest. You and I, as we learn more and more about programming and more about command line arguments, I dare say we'll become more comfortable with and tend to prefer the ability to customize commands using these command line arguments. Why? Productivity. It tends to make you faster because you get into the habit of knowing exactly how you can configure your software without having to manually answer questions. And case in point, all of this time, have we been running Python of something.py. You could imagine not doing that. You could imagine typing only Python, hitting enter, and then you're prompted for the name of the file you want to run. So you type in something.py, and then it runs. Not a big deal, but I would argue that over time, you're going to get a little tired of that tedium, and you would much prefer to just automate the command again and again and again, especially with little conveniences like being able to hit up and down in your keyboard history so as to rerun those same commands. Automation is big too. If you emerge from a class like this and start using Python to automate processes at work or for personal projects or the like, the ability to specify all of your inputs on the one line just means you can get work done more quickly. So hands down, absolutely, using command line arguments is a more arcane feature of systems that most of us are no longer as familiar with because of Windows and Mac OS and other operating systems that have buttons and GUIs and menus. But the more comfortable you get with programming, I dare say the more you will tend to prefer these capabilities because they allow you to do things more quickly. With that said, allow me to propose that we take a turn toward yet another package that's particularly popular and just as easy to install, all toward an end of using APIs. Now, APIs are not something that's Python specific. More generally, an API is an application programming interface, and it can refer to Python files and functions, but often APIs really refer to third-party services that you and I can write code that talk to. Many APIs, but not all, live on the internet these days, so that so long as you have a browser or so long as you have some experience with Python programming or programming in any language, you can write code that in effect pretends to be a browser, connects to that third-party API on a server, and downloads some data that you can then incorporate into your own program. Now, how do you do this? Well, Python has a very popular package that you can install via pip called requests. The requests library allows you to make web requests, internet requests, using Python code, essentially as though you were a browser. Tends to be a browser, connects to that third-party to Python files and functions, but often APIs really refer to third-party services that you and I can write code that talk to. Many APIs, but not all, live on the internet these days, so that so long as you have a browser or so long as you have some experience with Python programming or programming in any language, you can write code that in effect pretends to be a browser, connects to that third-party API on a server, and downloads some data that you can then incorporate into your own program. Now, how do you do this? Well, Python has a very popular package that you can install via pip called requests. The requests library allows you to make web requests, internet requests, using Python code, essentially as though you were a browser yourself. You can automate, therefore, the retrieval of URLs that start with HTTP or HTTPS. The documentation for this library is at a URL like this, but it too can be installed at the command line. And even though it's third party, it's one of the most popular and commonly used packages out there in Python. And this too is one of the reasons, again, that Python is so popular. There's just so many solutions to problems that you and I have or are invariably going to have when we write projects of our own. There's just a really vibrant ecosystem, a really vibrant community of open source software that's that easy for us to install. Let me go back to my terminal window now and run pip install requests in order to install this package on my own system. And after some lines of output, I'll see that it's successfully installed. Now let's go ahead and create a new file here. For instance, iTunes.py. It turns out that Apple has its own API for their iTunes service, the software that provides you with the ability to download and search for music and songs and other information as well. And it turns out that, let me go back over to my computer here and open up a browser like Chrome, and let me go ahead and visit this URL here, https://itunes.apple.com/search, !entity = song, ampersand, limit = 1, ampersand, term = Weezer. Now, I constructed this URL manually by reading the documentation for Apple's API, Application Programming Interface for iTunes, and what they told me is that if I want to search for information about songs in their database, I should specify entity = song, so that it's songs and not albums or artists or something like that. If I just want to get back information on one song, I'm going to provide limit = 1. And if the band I want to search for, the artist, is Weezer, I should specify term = Weezer. So with this, if I go ahead and hit enter and visit this URL, I actually end up with a text file in my downloads folder on my Mac. If I go ahead and open that text file that my browser just downloaded, we'll see all of this text here, which at first glance might look a bit cryptic, but it actually follows a pattern. Notice this curly brace at the start, and notice this closed curly brace at the end. Notice this open square bracket here, and notice this closed square bracket here. And in between those pieces of syntax are a whole bunch of strings and values. In fact, a whole bunch of key value pairs. What we're looking at here is a standard text format known as JSON, JavaScript Object Notation, which, yes, is technically related to yet another programming language called JavaScript, but JSON itself is typically used nowadays as a language agnostic format for exchanging data between computers. By language agnostic, I mean you don't have to use JavaScript. You can use Python or any other language to read JSON or write it as well. And it's a completely text-based format, which means that if I visit that URL with my browser, what gets downloaded is just a bunch of text, but that text is formatted in a standard way using curly braces and square brackets, using quotes and some colons that ultimately contains all of the information in Apple's database on Weezer's song, at least the first one, because I limited it to 1, in their database. And that's an API, an application programming interface, a mechanism whereby I can access data on someone else's server and somehow integrate it into my own program. Now, of course, my browser, Chrome, is not something I wrote. I should actually write some Python code that perhaps pretends to be a browser to grab this same data. So let's do that. Let me go back to VS Code here, and let me write a program with code itunes.py. And we're going to write some code via which I can then use the iTunes API and in turn Python to get information about any band that I might want. I'm going to go here and import first the requests library, which I installed earlier in order to make those HTTP requests. I'm going to go ahead and import the sys library, via which I'll have the ability to use command line arguments like specification of the band that I want to search for, if not Weezer. And then down here, I'm going to go ahead and insert some error checking to say if the length of sys.argv does not equal 2. So if the user does not provide me with the name of the file they want to run and the name of a band, and that's it, you know what? Let's just go ahead and exit for now. I could provide a more explanatory message, but for now I'm going to keep things simple and just exit the program prematurely so that I can trust hereafter that sys.argv has what I want. And now I have the opportunity to use the requests library to write some Python code that effectively is pretending to be a web browser so as to connect to that same HTTPS URL on Apple's own server. So now that I've guaranteed that the user has typed in not just the name of the file, but also the name of a band at the prompt, giving me a length of 2 for sys.argv, let's go ahead and execute requests.get, which is a function inside of the requests package that will literally get some response from a server. And the URL that I want to get is exactly the same as before, https://itunes.apple.com/search, entity equals song, ampersand, limit equals 1, ampersand, term equals previously Weezer, but let's make this program a little interactive and actually allow the human to specify at the command line what artist they'd like to search for. So I'm going to go ahead and close my quote early and just append, using the concatenation operator as in the past, sys.argv bracket 1. And now it'd actually be nice to store the response from the server in a variable. So I'm going to go ahead and say response equals, and to store all of the response that comes back from the server in a variable called response. Down here now, I'd like to just understand what the server's returning to me to make sure I know how next to proceed. So this isn't going to be very pretty yet, but I'm going to go ahead and print out response.json, which ensures that the data I'm getting back is formatted on my screen as exactly that, JSON, the same text format as we saw on my screen. It's not a useful program yet. I'm really just learning along the way. But let me go ahead now and increase the size of my terminal window and run Python of itunes.py and type in the name of a band like Weezer and hit enter. And what we see on the screen, formatted almost the same as before, is exactly that same text. But what you'll see here is that this has been standardized now as a Python dictionary. What indeed Apple's returning is technically a JSON response, JavaScript object notation, but Python, the requests library, is converting it to a Python dictionary, which happens to use, wonderfully coincidentally, almost the same syntax. It uses curly braces to represent the dictionary here. Library is JSON response, JavaScript object notation, but Python, the requests library, is converting it to a Python dictionary, which happens to use, wonderfully coincidentally, almost the same syntax. It uses curly braces to represent the dictionary here, and a closed curly brace to represent the end of it here. For any lists therein, it uses a square bracket here and a closed square bracket down here. It uses quotes, single quotes in this case, or equivalently double quotes to represent the keys in that dictionary, and after a colon, it stores the value of that key. And so you'll see that indeed we have a result count key whose value is 1, but then a more interesting result key called results, whose value is this entire list of data. Now, honestly, this is such a big blob of text that it's going to take me forever to wrap my mind around what I'm seeing. So let me propose temporarily we use another library in Python that will allow me to format my data a little more cleanly. It turns out that Python also comes with a special library called JSON that allows you to manipulate JSON data and even just print it. That is formatted in a way that's going to be way easier for you and I to understand. So let me go back to my code here. Let me shrink my terminal window. And let me propose that just temporarily, again, we do this. Let me import this additional library, JSON, which comes with Python, so I don't need to install it manually with pip. And let me go ahead now and not just print out response.json, which was that big blob of hard to understand text. Let me go ahead and use one other function here called json.dumps for dump string, and pass to that function that response.json return value. So again, I'm just introducing another function who I claim it has a purpose in life of pretty printing, nicely formatting on the screen the exact same information. And I know this from the documentation, having done this before. But I'd like things to be nicely indented, and according to the documentation, if I passed in a named parameter of indent equals 2, that's going to indent everything at least 2 spaces. I could do 4 or something else, but it's going to be enough to help me wrap my mind around what the data is I'm getting back. Because again, I'm just learning along with you. So let me increase the size of my terminal window again. Let me run Python of iTunes.py. And again, let's search for Weezer and hit enter. And now notice it's still a little bit cryptic because there's a lot going on here. But my gosh, I can totally read this more easily now. Notice now that I still see the first curly brace, which means, hey, this is a dictionary in Python, a collection of keys and values. The first key is called result count. It happens to be displayed in double quotes now, but that's just an issue of formatting. It could be double or single so long as we're consistent. The value of that key is 1. Why? Well, I told the URL to only limit the responses to one Weezer song, so I've gotten a result set of 1. If I increase that limit, I could probably get more. Then the interesting part of this response is really the data itself. Notice in the results key here, there's a really big value. The value is a Python list, as implied by this square bracket. What does this list contain? Well, I know from skimming it earlier that this contains one dictionary, and that's why we see another curly brace here. So again, if this gets a little more complicated, keep in mind that a dictionary is just a collection of key value pairs, and Python uses curly braces to indicate as much. It is perfectly reasonable for a dictionary to be inside of another dictionary if the value of some key itself is another dictionary. So this is a common paradigm, and even though it might seem a bit cryptic, it's just something that allows us to associate more keys with more values. Now, most of this information I probably don't care about. For instance, according to Apple, the unique identifier for Weezer is apparently 115,234. That might be useful if I'm making my own database and I want this to be searchable, but for today's purposes, all I care about is the name of the track, otherwise called track name as key. And the first song, and only song, because we limited it to 1, that we got back from iTunes here is the song that you might know by Weezer called Say It Ain't So. So now I have a bit of a clue. If my goal here is to implement a program called iTunes.py that doesn't just dump the response from the server, which is admittedly very cryptic, but to print out all of the songs that iTunes has for the band called Weezer, maybe I can iterate over this somehow. So let me backtrack. Here's the key called track name. It is inside of a dictionary that is the value of results here. So how can I go about getting this? Well, let me go ahead and try this. Let me go ahead and shrink my terminal window back down. And let me propose now for one final flourish, we don't just lazily print out the contents of that response, because that's not interesting or pretty for anyone. Let's do this. Let me go ahead and create a new variable, just for the sake of discussion, called we don't shrink, just lazily print out the contents of, and let me propose now for one final flourish, we don't just lazily print out the contents of that response, because that's not interesting or pretty for anyone. Let's do this. Let me go ahead and create a new variable, just for the sake of discussion, called O for object, and I'm going to go ahead and call O equals response.json, just to store that JSON response specifically in a variable called O, but I could name it anything I want. And now I'm going to do this. For each result in that object's key called results, go ahead and print out that result's track name. And notice I have used exactly the same capitalization. Track name has a capital N. Results is all lowercase. And let me rewind before we run the actual program. In line 8, we are making an HTTP request using Python to the server, just like you and I as humans type URLs into a browser and hit enter. This is the Python equivalent thereof. I am then on line 10 just grabbing from that variable that contains the server's response the JSON object that I care about, the thing between those curly braces at the very top and the bottom. But because we've poked around and because I read the documentation earlier, I know that that object has a key called results. And that results key, again, is a list. Now, at the moment, that list contains only one song, Say It Ain't So, because I limited my response to 1. But even so, my loop will work. It's just going to iterate once. And each time through that loop, it's going to print the current results track name. If I want to make this even more interesting, let me change this limit now from 1 to 50, so I'll at least get back 50 track names instead. Let me go ahead now and increase the size of my terminal once more and go ahead now and run Python of iTunes.py, searching again for a band like Weezer. And here we go. And voila, there are 50 songs that iTunes has for Weezer. And if we scroll back up to the top here, we'll see that The very first one there is indeed Say It Ain't So, but now we got Undone, the Sweater Song, Buddy Holly, apparently another rendition of Say It Ain't So, perhaps from another album, another Buddy Holly, Undone, My Name is Jonas, and so forth. Questions now on this program, which integrates Python with a real-world third-party API.
Yeah, hi. Can we use break instead of system.exit?
Good question, but no. Break, again, is used to break out of things like loops, like we saw earlier. Sys.exit is used to break out of the whole program itself. Use break for loops for now, and use sys.exit to terminate the whole program. Good question. Other questions now on this program or others?
From where we bring the name of the key results?
From where do we get the name of the key?
Results itself. Can we change the results name?
You cannot. So we could in our program. So the keys that come back in that JSON response, to be clear, come from itunes.apple.com. Some engineer, some team of engineers decided for us what all of those keys would be called, including track name, results, result count, and everything else. You and I can absolutely store those same values in variables, just like I'm doing here with O, just like I'm doing here with result. You can rename those keys anything you want using Python variables, but the JSON response is coming from that third-party server. Other questions?
Yes, sir. So I have a question related to cowsay package. So yes, sir. So sir, what sort of ASCII graphics is it capable of outputting?
The cowsay package. I would refer you to the URL in the slides earlier, if only because it's more thorough. They have not just cows, but Tyrannosaurus rexes and several other animals as well. I should emphasize that this is not a package I suspect you will use much in the real world. It's really just meant to be representative of the types of packages you can install, but allow me to refer to the documentation for what more is there. But ASCII art is all we had before there were emojis, let alone GIFs and JPEGs and PNGs, but it's what is immortalized in cowsay. Well, allow me to transition us back now to one final capability of Python, which is that you yourselves have the ability to make your own libraries. Up until now, we've been writing all of our functions in our one file, hello Py and everything since. And now that we've introduced